Okay, here's a couple of questions with logarithms. Um, and it's basically an understanding question of what logarithms are. Like this top one here, 14, log of 100. If there's no base indicated, like in this one or this one, the base is assumed to be a 10. So this question is really saying, to what exponent must I raise 10 to get 100? In other words, 10 to the something is equal to 100. Well, I know 10 squared is 100, so the answer to this whole thing is 2. So 10 to the second power gives me 100. Similarly, in this one, to what exponent must I raise 8? 8 raised to some exponent, let's call it x, to get 2. Well, that's a little bit funny one because this number's smaller than that one, right? But I could, to solve that, I could think of square rooting or cube rooting. In this case, it would be a cube root. And another way of writing a cube root is 1/3. So, and if you try that on your calculator, the cube root of 8 does come out to 2. So the value of this whole expression is equal to 1/3. One other way that you could have done this question is using same bases. So if I have 8 to the x is equal to 2, I could try and get these to be the same base, because 8 I know is the same as 2 cubed, right? And power of a power, this would be 2 to the 3x is equal to 2. And then this is the, if I have the same bases, the exponents also must be the same. So 3x must be equal to whatever the exponent here is, and when none's written, it's assumed to be a 1. So if the bases are the same, then 3x must be equal to 1. Divide both sides by 3, and you get the same thing, a third. This question's a little bit different because it's using a different logarithm, right? It's a ln is the same as log base e. So in this question, and I like to rewrite them. Maybe I'll use a different color. I like to rewrite ln, so just this ln bit is the same as log base e. Okay? And then I'm taking the ln of e, or the log base e of e. So this says, to what exponent must I raise e to get e to the first? Well, I just have to raise it to the first exponent. So the answer to that one would be 1. Now, if you do this on your calculator, you could go, maybe I've got my calculator here. Yeah, here we go. So I could go ln, but then I have to get e, which is that one right up there. So I could go second e. It's asking me for an exponent. We'll just use 1 so we don't mess things up. And close my bracket and say go. Comes out to 1. So ln of e is the same thing as log base e of e. And that rule where this is the same as this, so if you're taking the log, let me do another example. If you have log base 10 of 10, the answer is 1. If you have log base 7 of 7, the answer is 1. If you have log base star of star, it's equal to 1. Okay, so that's that one. Now this one here is a little bit different. It's asking log base 10 of 1. So to what exponent must you raise 10 to get 1? Again, we're going down, but this, where you have a 1 there, that's sort of a special example. Because, let me rewrite this one. So they're saying 10 to some exponent is equal to 1. Well, the only way you can get a 1 there is if this exponent is 0. Because anything to the exponent of 0 is equal to 1. If you have 10 to the 0, that's 1. If you have star to the 0, that's 1. If you have e to the 0, that's also 1. Okay? Hopefully that helps you with those questions. Now you had a couple other ones. Ln of e to the 3/4. Let me rewrite that. So ln is the same thing as log base e of e to the 3/4. Okay, now this is the power rule. If I have any exponent here, I'm taking the logarithm of something where I have an exponent there, I can bring that out front. So that 3/4 can be out front, so 3/4 times log base e of e. And remember, this log base e of e, I could put an exponent of 1 there if I wanted to. So to what exponent must I raise e to get e? First exponent. So this whole thing here is just equal to 1. And 1 times 3/4 is just equal to 3/4. Okay, maybe that's something to do every time you see ln. If you see ln, just rewrite it as log base e of whatever they give you. That helps me solve that one. Last question is a graphing one. Graph the function and its inverse. Use any method. Ooh, I might just use my calculator. Here's my calculator right here. So I want to graph something. So y equals, what am I supposed to graph now? 3 to the x. So 3 to the x. Where's my x? Right there. Okay, graph. So there's my graph. So it just has that normal exponential looking function. Now notice that with any inverse function, they always have to have a mirror on this line y is equal to x. So when I graph the logarithmic function, it better be sort of mirroring this thing here on that line. So it's got to look, you know, something like this. It's going to be, yeah, something just like that. Let's try it. So y equals log, oh, I already got that, no, I won't leave that one. So log of x, close my bracket, graph me. And there it does. Maybe I should zoom in on that part. Let me zoom in right there. I don't know if that lets me do it. Oh, there we go. There. So there's the y equals 3 to the x, and there's the y equals log of x, or log base 3 of x. Oh, I was supposed to do log base 3. I didn't do log base 3, but it's the same kind of principle. Maybe I should change that first one to 10 to the x. Uh-oh, delete that thing. 10 to the x and log of x. So these two are exact inverses. I hit graph, there's the first one, and there's the second one. And they are mirrored on the line y equals x. And that's what you'll see for all of the questions in on that section there. If you wanted to, another way you could have done it is just start plugging in some values. So here's x, here's y. Plug in 0 for x, 3 to the 0 is equal to 1. Plug in a 1 for x, 3 to the 1 is 3. Plug in a 2 for x, 3 squared would be 9. Now, go over on this one and let's try the same kind of thing. But this, I guess this time we're also plugging in values for x. So, I can't plug a 0 in there because you can't take the log of a 0, I don't think. But I could put a 1. So, log base 3 of 1. To what exponent must I raise 3 to get 1? Has to be a 0. Oh, that worked. Let's plug a 3 in there. So if I put a 3 in there, log base 3 of 3 would be whatever this exponent is. To what exponent must I raise 3 to get 3? It'd be first exponent. Notice that these things are swaps of each other, or they're inverses of each other. So what I would assume that if I plugged a 9 in for x here, I better get a 2 out. So log base 3 of 9. To what exponent must I raise 3 to get 9? Has to be a 2. Then I could take and I could graph those. So this first one, 0 and 1, that's a point 1 and 3, another point 2 and 9, another point up there. So I'm getting a exponential looking graph. Whoops, that shouldn't have gone across the axis like that. Not that one. And then this one, 1 0, 1 0 would be, yeah, that was right. 1 3, yeah, 1 0 would be right there. And then 3 1, so 3 and 1, and 9 and 2, something over there. I could have done one down here like a half. If I'd have done x is a half up there, I would have got a fairly small number. But anyway, the graph is going to look something, okay. Oh, my graphing skills aren't well, they're pretty good, but it's my pen. My pen's a problem. And the point of the whole thing is that the two are mirror images across that blue line there. All right, hope that helps with those couple of questions.